Take two. Good afternoon, everybody, and welcome. Thank you for joining us today from Ellensburg, Washington, USA. The local time is 1:47, and we will begin our program at the top of the hour, 13 minutes from now. Most of you watch this as a replay, so go ahead and scrub ahead 13 minutes if you like for the beginning of the program. But for the rest of us, let's say hi to a few folks. I am 5x5 after remembering to turn on my microphone. Wonderful. Let's say hi to you. Where are you viewing from? And then I will email the guest who you know. Scrolling back, slowing down the chat. Nova Scotia. Hello, Nevin. Yorkshire, UK. Bourne, Texas. Vinman's Bakery. It looks like Jeff's with us in some form. Como, Colorado. San Diego, California. Still back a ways. Sonoya, Georgia. Minneapolis, Minnesota. Springfield, Oregon. Hello. Loving the Butler book on paleomagnetism. Guess I am a nerd, says Dr. What's her name? In Portland. Yeah, I guess you are a nerd. Good job. That's tough sledding for me. Maybe not for you. I don't know. That's good. Windsor, Colorado. Houston, Texas. Mountain View, California. Boise, Idaho. Marysville, Washington. Omak, Washington. Cologne, Germany. Automatic scroll down to live. Why not? Let's roll with it, baby. Roll with it, baby. Roll with it, baby. Bergen, Norway. Capac, Michigan. Wisconsin Rapids, Wisconsin. Deering, Kansas. Half Moon Bay, California. Hayward, Wisconsin, perhaps, or California. Pasco, Washington. Vienna, Austria. The Netherlands. Scarborough, UK. Coaching up on pronouncing certain things. Thank you. Ottawa, Canada. Kamloops, BC. Spokane, Washington. East Tennessee. Okay, well, let me email Bernie. Make sure we don't have a problem there. I'm glad we're 5x5. Thank you for those kind of automatic reports. You guys are veterans now, for sure. And hopefully Bernie will remember us. It's a school day, you know. There's plenty going on in the hallways and people wanting to chat. I'm like, hey, I got to get in there. And well, why? You teaching? I'm like, well, yeah, kind of. Oh, yeah, I am, but they're confused. What? That room's empty. Well, let me tell you about what I've been doing one of these days, but not now. Bahamas, greater good. Hey, you're tuning in from the Bahamas. That's wonderful. Santa Clarita, California. Birch Bay, Washington. Nina is in Norway. Hello. Excuse me. A geologist. That's John Encarnacion from the mid-continent of North America. Old former classmate of Bernie's. Hey, John, I'm a big fan of yours. And everybody, if you're not aware of if you use Instagram and you don't know the Instagram account, A_geologist, I think that's what it is. John has a tremendous following and he is gifted in many ways. And Randy Ankin is with us. Hi, Nick. Randy Ankin, Geological Survey of Canada, Sydney, BC is here. Oh, that's wonderful to have you live with us, Randy. Randy will be our guest in a couple of shows from now. Okay. All right. So waiting on Bernie. For reasons I'm going to share with you. Well, let me do it now. Bernie's got a 3 o'clock meeting. It's, we're going to start at 2. So the plan is for me to be extra brisk, 10 minutes or less, for me to just set the tone, set the hook, tell Bernie of a few ideas that I'd like to talk about, and then we're going to go to him because he's going to have to be gone by top of the hour. He's going to have to be gone by 3. So a little different in format. I guess I'll remind everybody of that once we start at the top of the hour. So that's a little different for us. And when we're done with Bernie, I think I'll just take my time and do some stuff on the laptop, and other things I have in mind. Let's say hi to a few more of you, and then we will start getting serious about this. I'm excited for today. I have a laundry list of questions. We already know Bernie. I was going to say some other stuff there. I guess I'm not. Hey, Philip says Lipton iced tea is brisk. All right, you're really drinking iced tea? Are you in the Southern Hemisphere or something? I mean, it's over freezing here. I rode my bicycle for the first time today. You know, do you ride bikes in town when there's a thaw and you're like huge puddles, and then you're like steering through compact snow and ice and all that? But it's over freezing. I miss riding my bike. Bernie's in the green room. Great. And if you want to share that screen right away, Bernie, I think we would have use to go back to a few. I assume you have some other slides for us. If not, no big deal, but you'll see what I have in mind. So great. Glad to have you in the green room there, Bernie. Thank you. North Bay, San Francisco. Saber is in Loreto, Baja California, South Mexico. And yeah, we got 475 already. That's nice. That's really nice. Thank you. Fans of Paleomag. Well, why not? We've been building this thing up since the first session. We're finally here. Melbourne, Australia. Great Falls, Montana. That's Moonshiner 54, for those that must know. Joan and Tim are both age 77 and 78, respectively, in Bend, Oregon. Thank you for joining us today. Everybody saying hi to Jeff. I thought Jeff was down in Yakima today. Whatever. He's maybe on the road. Eric wanting to start early. I appreciate your eagerness, but no, I want to, some people join us right at the top of the hour, Eric. Andre is in Bonaire, Dutch Caribbean. Hello, live from gloomy Central Washington. Rainy Boulder Creek, California. Yeah, all that rain down in California. Hope everything's okay for all you guys. Man, crazy. Updates on Jeff from Vindman's. All right. So I think it's approaching 5 minutes to the top of the hour. Let me do a couple of programming things now, because I don't want to waste up valuable time after the top of the hour. So especially for those of you that are new to us, this is our routine. And we are like clockwork here every Wednesday afternoon at 2 p.m. Pacific, every Saturday morning, 9 a.m. Pacific. Today is session O. Saturday morning will be session P, and so on. And we're going to Z. And Z will be the Saturday of the 3-day weekend here in the States. No idea what's happening in February. Oh, I got a couple ideas, but mostly I don't have an idea. And that's on purpose. We just see what these guests have to say, and then we just kind of follow as we go. Also reminding you, you've seen this a number of times now, but 2 more Paleomag shows after today. Jane Wynn on Saturday, and Randy Enkin, who's with us live from Sydney, British Columbia, will be joining us a week from today. Then we switch gears and have Karin and Mitch Mahalanik on Saturday, January 21st. Stephen Johnston, a couple of Bob Hildebrand shows, and then who knows after that. All right, I think all systems go. I have one quick question, just testing-wise, for you viewers. For those that care about such matters, what resolution are you viewing right now? Like if you go down to your gear icon, those that care about this or know what I'm talking about, I've upgraded my OBS thing, and I'm just curious if you're viewing on 1080p or 720p. And I'm also curious if you were unable to watch 1080p until the last couple of shows. And if that's true, then my upgrade worked. And you may or may not notice any difference in clarity or visibility, but it just makes me happy that a bunch of you are watching 1080p. That's great. And yeah, I'll watch the replay and see these, but if you could also just comment on before Christmas, could you only go up to 720? Like, were you watching 1080? Were you watching any of these live streams before Christmas in 1080? I don't think you were. I'd be curious, just however you want to phrase it. Like, and again, does the visual, does the camera look crisper, and so on. Of course, I'm jinxing it, but I think this upgrade in OBS means we're not going to have as many crashes. Maybe we will not have another crash the rest of the alphabet. Why did I say that out loud? Stupid. All right. I need 2 minutes to get my head right. Can I ask one more time, are we 5 by 5? We should be. Delay in the comments. Can I ask one more time, are we audio and visual loud and clear? And if so, we are going to start in 2 minutes. Great. Thanks, everybody. Hope you enjoy this episode. Hot mic. Hot mic. Hot mic Eddie. Michael Patterson Eddie. He's hot. Okay, don't get flustered today because you're going to the guest much earlier than usual. You can't do a slow ramp up. You can't do a slow build. You got to get to it quick. You got chalkboards. You're not going to go to laptop before Bernie. You're not going to go to laptop. But you've got front and back boards, and I think it's worth looking at all those, don't you, boy? I think it's worth looking at all those quickly, just to give Bernie some thoughts on where he wants to go with this. You can slow down, take your time after you're done with Bernie. But Bernie is the featured guest yet again. And this is a rare chance to learn from somebody who has deep knowledge. So how about you shut your mouth for a little bit? How about that? How about you clam up and listen to the guest? That'd be nice for a change. You don't know the order of the boards, do you? Let it flow. Let it flow. You don't have to know what you're talking about. You have a guest. You don't have to know it. You just lob some stuff out. You can do this. Come on, let's go. Come on. Come on, you can do this. Good afternoon and welcome to this Bernie Housen Part 2 episode. We had Bernie Housen in the last show, and here he is again, coming in just a few minutes. I'm not going to screw around. I'm going to get to Bernie as quickly as possible, but I do want to do a few things on the chalkboard just to prime the pump, just to continue a few narratives that we did in the last couple of shows, and also to give Bernie some real-time ideas about what we might talk about here before he leaves for his meeting at 3 o'clock. I think the Basil Tikoff show and the first Bernie Housen shows are required viewing to really get what's going on in this show. So if you're watching this one in replay, thank you for watching, but I think I'm going to ask you to stop, please. Go back and watch Basil Tikoff and Bernie Housen after Christmas. The hit and run Basil show, Bernie giving us some basics about Mount Stewart batholith, was it folded or not, and other details from Bernie in the last show. Okay? That said, what's the plan today? Well, here's what I'd like to do, Bernie. We'll see where you want to go. I want to talk more about Paleohorizontal. We want to lean into that pretty heavily, and I want to convince the viewers why talking about Paleohorizontal, why Paleohorizontal is such a crucial matter. And Bernie has experience not only with plutons. Bernie Housen, our guest today, has experience with doing paleomag, drilling with drills into rocks that are lava flows, and dealing with sedimentary rock layers as well. They all yield paleomagnetic results. And Bernie has done a lot of work recently to recalculate or rework or redo somehow, I'm fuzzy on that, Bernie, what you've done with the old papers and the old data, and has it changed substantially? but paleohorizontal is important. After that, a little bit from me on something called a paleogeographic pole position. I've always kind of casually known about it. Now I think I know more. I want to learn even more from Bernie today. And then a little bit of social science, if we have time with Bernie. What's he been up against? Who has been looking at the work he's been doing? Who has just ignored it? And I think most have ignored it, to be honest, but we'll let Bernie speak for himself. Okay, let's start with paleohorizontal. When I talk to field geologists out in the field, many of them who I admire and respect say, I just don't believe that paleomag, especially from plutons. How can you get a paleohorizontal from a pluton? Well, in the last show, Bernie was talking about the details of how to establish a paleohorizontal, an old horizontal surface before something happened, if something happened. Well, I'm not even talking about folding now. I'm just like, why is paleohorizontal such a huge issue with paleomagnetic studies? Here's the Geology 101 version, not even that probably, geology, remedial geology, okay? The idea is if you have a horizontal surface, a horizontal axis, and then you have the measured orientation of a grain within a granite, we'll just use a pluton, but it works for the other kinds of rocks as well. You're drilling into that rock, you're carefully measuring that core of that rock that you're going to pull out of the bedrock, and you're getting an orientation of that ferromagnetic grain, that magnetite, that hematite, that pyrrhotite. And the idea is you're measuring an angle, ultimately, you're measuring an angle between horizontal and the orientation of the grain today. That angle is an inclination. And the concept of having batholiths like the Coast Plutonic Complex with shallower than expected grains or inclinations, the Sierra Nevada batholith, which has steeper or less shallow inclinations, the Peninsula Ranges batholith down in California and northern Mexico, these shallow inclinations, these shallower than expected inclinations is the key to the whole thing. Why? Daryl Cowan did this in session B. I'm going to do it very quickly as well. Here's our planet, there's the equator, and here are orientations of a pink piece of chalk. Invisible magnetic field. Magnetic field comes out of the planet vertically at the poles. The magnetic field is horizontal at the equator, horizontal to the surface of the Earth, and then it's again intersecting the surface of the Earth steeply at the South Pole. So if you have a lava flow that's cooling in a volcanic eruption at the equator today, those orientations of those ferromagnetic grains are going to be horizontal. Horizontal. If you look at a lava flow cooling at the North Pole today and lock in those ferromagnetic grains and get a paleomagnetic result, you have a vertical orientation of those grains. The key is, because of this invisible field, and maybe Bernie's got another slide to share with us, we have gradually steepening inclinations depending on our latitude. So those shallow inclinations from the Mount Stewart batholith are telling us, there's the inclination right in there. That my nose is the angle between the chalk and the surface of the ball. That shallow inclination tells us that that magma or that lava flow cooled closer to the surface of the Earth, closer to the equator than it is now. Shallow inclinations, unexpected inclinations, discordant inclinations of magnetic grains. More coming on that, more coming on this. Let's get rid of this. In the hit and run paper that we are featuring and have been for much of this series, 2023 paper by Basil Tikoff and Bernie Housen, here are some key sites. Now, we don't have to do it all today. We have 2 more Paleomag shows, and some of those guests are experts in some of these locations. But Bernie has highlighted a few sites that are excellent for paleomagnetic results, according to Bernie. part of the insular superterrane. Here are the sites that keep coming up just verbally in these conversations. There's others in the paper, but these are the ones that I want to include. The intermontane superterrane. Dancing chalkboards. Will we do something with this? And again, we have, now this isn't even worth it. So here are these insular paleomagnetic spots. Here are some intermontane paleomagnetic spots, Blue Mountains, Ochoco Basin. Churn Creek shows up twice. I don't understand. Mount Tatlow, next show. Nanaimo, Mount Stewart Batholith, and others. There's plenty of paleomag up in BC and the Yukon that doesn't fit on our chalkboard. Get rid of it, semi-disappointing. Let's continue. Oh boy, now we got chalk flying. Can you see that? I'm rushing because I want to get to Bernie. Last chalkboard pair. Wow. The only thing I left on the chalkboard from the last show is this. And here's the detailed data from the hit and run paper from Bernie, telling us that Mount Stewart Batholith had its magnetization locked in at 90, even though that's a little bit younger than the age of the bedrock itself. And the old latitude of Mount Stewart Batholith, the original latitude, 31.3 degrees north latitude. Today, it's up here close to my town, 47.6 degrees north latitude. That's almost 3,000 kilometers of northward transport. Well, Bernie mentioned very quickly in the last show the Cooper Mountain Pluton. Did you catch it? And that jogged a memory of what I was doing in this room with many of you last winter. Does this look familiar to you? These are the flare-ups in the North Cascades that the Dream Team, Bob Miller, Stacia Gordon, and Mike Eddy have been working with for the last 5 years, that project that I'm part of. And we have 3 major magmatic flare-ups. Mount Stewart, part of the first one in the mid-Cretaceous. These 4 major plutons in the North Cascades of Washington, late Cretaceous, and then some Eocene plutons. And here's the Cooper Mountain that Bernie and a student worked on. My only point is, intersecting with last winter's series and this winter's series, we're too young with the crazy Eocene to have any of these funky paleomag signatures. They are concordant paleomagnetic signatures, meaning they agree with the paleopoles from the Craton. But Mount Stewart and presumably all of these guys have wildly discordant PMag signatures, shallower than they should be at their given latitude today. And Bernie, I'm curious, have you or anybody done work with the plutons in the North Cascades, these 4 guys, that are late Cretaceous? Interestingly to me, these plutons are invading from below while the proposed run is happening. And if you're like, hey, I tuned in to learn a hit and run model, well, we've already talked about it a fair amount, but in case you haven't gotten to the paper yet, the concept is Basil and Bernie are talking about all sorts of data now to confirm that we don't have a gradual, shallow subducting Farallon plate making the Rocky Mountains and making much of the American West geology. Instead, there's all sorts of new data sets, including paleomag, but not only paleomag, that suggests that there was a major hit of the insular superterrane 100 million years ago. And so the hit took 15 million years. 100 to 85 million years ago, we hit the orange and the yellow. We hit that stuff, or North America hits it. Doesn't matter. There was a major collision starting 100 million years ago in the mid-Cretaceous, but this paper and the paleomag says the hit is not the end of the story. Starting 85 million years ago, the orange and the yellow, at least cartoonishly, start moving north. They start running up the coast and deforming and continuing to build the Rockies during that time. Still fuzzy on that, by the way. Hit and run. Finally, 5-minute warning, Bernie. I'm going to do this quick because I still don't think I get it, but I feel like I need to give it the old college try. Paleomagnetic pole positions. I'm making progress, but I'm still not totally there. Here's the concept. The inclination is giving us paleolatitude. The declination of these measurements give us block rotation, clockwise rotation. Not interested in that right now. But the general concept, and Merle Beck kept saying this in these 2 long interviews I did with him. I rewatched those 2 interviews between last show and this show. Merle kept talking about Cratonic North America, sometimes called it stable North America. That's old North America. That's Laurentia. We can take Chicago, Illinois if we like on this map. This is all of North America. There's Florida. And if you pick a time, let's pick 90 million years ago, and we do paleomag from Arkansas and Massachusetts and Illinois and the Duluth-Gabbro, as Merle did for his PhD, and we plot where the magnetic North Pole was 90 million years ago for each of those locations in Cratonic North America, each of those sites in old North America are presenting a cluster of old North Pole positions. The magnetic North Pole 90 million years ago was here, a cluster of old magnetic north positions for the Craton. Slowing down for dramatic effect, and then we're going to Bernie. If we take rocks of that same age, remember, 90 million years old from the Craton, well, now let's find as many plutons, lava flows, and sedimentary deposits from 90 million years ago out here in accreted terrain country, exotic terrain country. And let's do the same thing. Let's plot those poles. Well, suddenly we realize there's not a cluster. Each of the studies from each of these individual terrains, in the insular, in the intermontane, there's no cluster. Something's going on. And Merle and Bernie for years have said those terrains have been displaced from their reference poles. The reference pole is over here, what we would expect. And those pole positions are discordant. They don't agree with what should be going on with the rest of Cratonic North America at that particular time, which got this whole concept going. Bernie, I'm getting my headphones. We're coming to you.
All right.
Bernie, how are you today?
Good. Can you hear me all right?
A little bit faint, but I think last time as well, it just kind of got a little stronger as we went. So I think we're good.
Yeah, your screen froze a couple times, and so it might be on my end, but let's just go.
Okay, let's just go. Thank you. So to properly introduce you, this is Dr. Bernie Housen from Western Washington University yet again. Thank you for your time once again. How's it been the last few days since we last saw you? Has there been a lot going on with Merle's passing, or that's coming down the road with activity and other things?
Yeah, a lot going on and catching up on stuff, and it's yeah, a lot going
everywhere.
on.
Yes, right. Well, especially grateful to you then for taking time yet again. Could you help me and all of us get a sense of the breadth of your experience with your work at Western? It's not just plutons. Can you kind of touch on the different key studies that you've been involved with over the last 25 years?
Well, yeah. So we've done a bunch of stuff in terms of this whole deal. I think re-looking at where Cratonal North America was. So we've reanalyzed data from Cretaceous rocks, which I have some stuff to show here that's out of that paper that Basil and I and others wrote.
Good. Can I bring it in? I'll bring it in. Oh, I'm sorry. Let me just finish your answer quick, and then I'll bring it in.
Yeah. There's also some, other things that are still unresolved. The biggest one in terms of where North America is where on Earth was it during the Jurassic? So that's a whole other story. That's a different set of studies. And then with terrains, I've worked in the Choco Basin and related rocks, and done a little bit with the Clarno volcanics. We've had students work in the NIMO group and other terrains. I've got some really good results from Kodiak, which might be something I can show really quickly to see how this, paleohorizontal is important and things like that.
Good. Yeah. Just one more before we go to the slides. So, no, we're going to the slides. Let's do it. This is good. I'm bringing you in, and anywhere you want to go, the themes that I'm after. So this is terrific, Bernie. Please.
Yeah, so that's kind of a good question. Where on earth to start? So this is just something where we collect oriented samples. We want to get paleohorizontal. We measure them in our lab. So we've got the picture here is our superconducting magnetometer. So we can measure the paleomagnetic direction recorded by the magnetic domains in all of those little minerals in the rock. We use the site location and the declination and inclination we measure to calculate this pole position. So I showed this on the last time. And this is the one that's kind of worth reiterating because, again, we have this model for the Earth's magnetic field, the geocentric axial dipole. And that's the geometry of the Earth's magnetic field over a long period of time, averaged together. So, 10,000 to 100,000. I think 100,000 years is best. So better time. And that relationship between inclination and latitude is part of this model. So with the geocentric axial dipole, this is the equation that you use to get paleolatitude. So this would be the latitude, and this would be the magnetic inclination.
Okay.
So we have to have the geocentric axial dipole to make this work. And, as you said in with the little poofy ball, the inclination angle is relative to horizontal.
Yes.
So we have to know where our rock was relative to horizontal when it was magnetized. So if we can't really demonstrate that, then everything else is way uncertain.
Can I interrupt you just right there? So
Sure.
Off the top of your head, what are a handful of studies that you or others have done where the paleohorizontal is just bulletproof, like we know exactly where that paleohorizontal is and there's not a concern?
Well, any bedded sedimentary rocks, there you go. We have to deal with inclination error. The very best are volcanic rocks. So the things that Ted and Jane Wynn and Randy and all those folks, the Mount Tatlow rocks. So we have sedimentary rocks and volcanic rocks all together. So you get excellent paleohorizontal from the sediments. You get excellent magnetic field from the volcanic rocks. And it's unimpeachable in terms of the relationship between horizontal and your magnetic inclination.
Thank you. I can't hold it. I got to ask one more thing. So there's this in your paper, and I think other papers I've read, it passes the test is the phrase. It passes the tilt test. It passes the compaction test. It passes the whatever. Is there a way to simply describe is it more complicated than it sounds, or you're just taking into account the context of the geology in those locations?
Yeah, you're doing two things, right? So you need to demonstrate that the magnetization is ancient and, as far as you can tell, was acquired when the rock formed. So we kind of are just applying cross-cutting relationships to magnetic directions. So if the rocks are tilted and the directions cluster best when the beds are tilted, well, that's probably not an ancient magnetization. But if you untilt the beds, change the directions, and that's when they cluster the best, then this is the way that the rocks were when they were magnetized.
Excellent. Thank you.
So,
okay, let's go back to more slides, and happy to continue with you, especially if you've got those maps with the paleo poles on them. That would be really fun to see.
Yeah. So I also showed this. This is the Cratonal one, right? So we do a reconstruction. So these average geocentric axial dipole poles are also the spin axis, right? So the pole is the spin axis. So we use that to make a reconstruction. So the figure on the right is where the spin axis was, which is where the North Magnetic Pole was. And so we put North America where the North Slope of Alaska, if it was attached, would be right there. So that's how we do this. And so what we do is we compare the accreted terrains. You know, essentially everything west of the strontium 706 line has been added to the continent. So we want to know where those things were relative to the craton. And so this is just on the right, this is a bunch of text, but essentially to look at this Baja BC problem, we're concerned with this specific amount of time, or this specific to know this, the paleo latitude of North America, and then we need to know the paleo latitudes of the different terrains, and then we're interested in data quality, so good age control, and we also want to make sure that we're using magnetizations of the right age for a tectonic model, and that isn't always done. We want those magnetizations to be well defined and dating from the Cretaceous. And then we need this paleohorizontal control, or if it's a sedimentary rock, we need to, evaluate this inclination error question.
So 50 years ago, did Merle have all three of those things at his disposal? For instance, I know he didn't have good age control compared to now, for instance. Is that one of the things you've done with some of these old papers, is use the more accurate, precise dates on things?
Yeah, so that's one of the things, and that we did a lot of work with both the results from the displaced terrains, which have more up-to-date dating, ironically or unironically, I don't know. But then we also went and did a good relook at the Craton results, and I can show you a couple examples of that, but what we found is that oftentimes, results from a really wide span of age were lumped together. And so we wanted to update the geochronology and then look at same aged results to see if there's any age progression of where the continent was during this period of time.
I see.
So pretty good age control. I mean, back in the, 60s, early 70s, KAR ages, whole rock stuff. It was decent. In a way, you're comparing an orange to an orange because you're using the same dating techniques on both the Cratonal rocks and the Baja BC rocks. For the Mount Stewart, in the 72 paper, there wasn't a measure of paleohorizontal. If you go back and read that paper, Merle and Linda did a good job of, here's one explanation. Well, maybe these are tilted. Here's another explanation. Right. Maybe the age is wrong. Here's another explanation. Maybe it's not tilted, and here's our microplate model.
Yeah. Great. Let's keep going.
Yeah. Let's see. The Craton. Let's talk about that for a sec.
Thank you.
So, this is just a table. This is an example of a really boring slide. But this is a table of some of the Cretaceous reference poles, and I highlighted a couple ones. And so, if we look at the, this one here, the Monteregian Hills, there's some intrusives in Quebec that kind of go out towards New Hampshire and into the Northeast. Another one is the Arkansas Alcalic province out in Arkansas. Right. So in this table, they're given an age. So this one, the Monteregian Hills, they're just down as 122 million years old. The Arkansas Alcalics, they're 100 million years. Okay. So if you look at the ages, though, you get some variation. So here's just a figure from one of the paleomagnetic papers of these Monteregian intrusives. So we have these directions. Okay. And here's another excerpt from a paper. And look at the span of ages of some of these intrusive rocks.
Yeah.
So they span quite a period of time. So one of the things that I've been doing is going back and finding the locations where the paleomagnetic results come from, finding locations where we have more up-to-date ages, and then kind of parsing them out by age. And this is a summary of what we find. Again, this is a busy figure, but if you start over here with this little chart, okay, the thing that looks like a barcode on the bottom is the geomagnetic polarity reversal scale. The age goes from 80 MA on the left, 150 MA on the right. Okay.
Yep.
So there we are. And each of these little boxes with the color code. So this orange box here, Newfoundland dikes, that's this one right there.
Yep.
Okay. So I've tried to color code them by area, and then I assign them to the age for those rocks. And so we see quite a spread. So like here, these red ones, right here, here, and here, those are 3 places in the Arkansas Alcalic province. So they span a considerable period of time. You might not want to compare the 88 million year old ones with the 102 million year old ones, for example.
Yeah, right.
Right?
Yeah.
The Monteregian Hills, they're over here. So they're on the older end. So these little blue colors, they don't span quite as much time, but they do. And then these open boxes, they're locations where the magnetic polarity was reverse, which is kind of important. So all of these reverse ones are coming from probably this reverse polarity interval right there. So what I did is just, average together the directions with these ages as a guide. Okay, makes sense?
Gotcha. Yep, it does. This is great.
And so here are the pole positions for the binned groups of ages. So there's a little bit of a difference between them. There's nothing systematic. You can't really draw any kind of path through this. So what this means is that, between 130 and, probably 88, 85, the continent has not moved very much with respect to the spin axis. Now, this doesn't mean it hasn't moved, but what it would require is that any plate motion has a pole of rotation, the Euler pole, that coincides with the spin axis. So North America, during this time, according to these data, was just moving in an east-west sense.
Wow. Yeah.
It wasn't moving at all north-south.
That my ears did perk up, or my eyes burned, or whatever the phrase is, when reading that paper saying that. And then are you implying then that starting 85 million years ago, North America starts drifting southwest? Is that what the paleomag is saying?
No, North America goes north after 85.
The Craton does.
The Craton goes north.
Oh, shit. Okay.
I'll show you that next.
Okay, good. Thanks. Sorry, Patrick.
So here we go. All right. So this gives us a good framework for the period of time between 130 and 85 MA.
Thank you.
Okay. There's less data from the latest Cretaceous. All right. So what I've chosen to do is I've used volcanic rocks from Montana. So 3 sets: Adel Mountain, Elkhorn, and the Cretaceous volcanics in the Judith and Moccasin Mountains. A little bit more scatter, smaller data set. They still kind of cluster, this pole right here, this EMK, that's the average of those other ones. So like if you averaged these, you get that. Okay. So these poles right here, the late Cretaceous ones, are farther from the Craton, which means, yeah, I said North America moved north, didn't it?
Yeah.
I got that backwards. The pole moved north, the continent moved south.
Okay. All right.
Need something to drink.
Yeah, there you go. So that change is happening roughly 85 million years ago, which is that what I'm getting at, and I may be making too much of it, is that, a common critique of Baja BC that these reconstructed ocean plates are moving way too fast north based on what we know about plate motions, and is a potential drifting south of the Cratonic North America helping with that at all? Or is it worth thinking about that Craton's moving south?
Yeah, it's definitely worth thinking about. So, yeah. The other thing, and this could be a whole separate song and dance, but most of the plate models that, you look at the motion of the oceanic plates using the polarity stripes and the transform faults and Euler poles and all of that.
Yeah.
They use a hotspot reference frame. And we know from the paleomagnetic data from the Hawaiian Emperor hotspot that the hotspot moves at plate rates. So there's another fly in that ointment.
I mean, that's a perfect example of how field geologists are dealing with paleomag data, and they're like, I just can't think of that. That just screws up what I'm doing. I'm guilty of that when I teach mantle plume stuff in my classrooms. I can't deal with mantle plumes moving because it's very difficult for me to handle that.
Yeah, when I teach physical geology or geophysics or something, I start off by saying that all your textbook authors are lying to you.
God. Because
you have that, fixed hotspot model.
Yeah. Wow. Okay.
Yeah.
Well, we're still Cratonic pole positions even here, and I know we're heading to what things look like when we get away from the Craton.
Right. So, I guess it depends on how far you want to jump in. So I have little excerpts of some of these studies. I could go talk about, as an example, the rocks from Kodiak. I have those teed up kind of last on my set of slides, but I can just zip through those. It's not a bad example. And then we can look at the Baja BC model at, the older time frame and the younger time frame.
That sounds great. I know nothing about the Kodiak stuff. I'm very excited right now.
Okay, so I'm going to zip through this and look at all this fun stuff.
You've been busy.
Okay. Oh, here we are. Okay.
Wow.
All right. So this is a Paleocene Eocene story.
Okay.
So this is a figure. And what it's showing is that there's a whole belt of Eocene-aged rocks that are anomalous in that they're too close to the trench. So they're four-arc volcanics.
Mm-hmm.
And they go from Kodiak Island up here in the Aleutians all the way down to things that are closer to here and in Oregon, down in here. Okay.
Yep.
So if we look at the ages of these rocks and how far they are from that, Aleutian end, the Kodiak Island one, right?
Mm-hmm.
So this is just distance from that island. You see this regular progression in ages from older to younger.
Mm-hmm.
And you can kind of sort of see something similar over here.
Yeah.
So the idea, because we have these volcanic rocks that are formed in the forearc, is that these are recording a type of a plate triple junction, a trench ridge trench triple junction. That takes some careful thought to say. Essentially, we're subducting a mid-ocean ridge.
Mm-hmm.
Okay, so what's moving? Is the triple junction moving or are the rocks moving? So this is a figure from a paper that Peter Heusler wrote with other co-authors in invoking what they call the resurrection plate model. So essentially what they're saying is that this is one of the trench ridge trench triple junctions.
Yep.
This is the other one down here. And as this plate subducts, the triple junction goes like that. Okay?
Yep.
For that to happen, you know, all of these volcanic rocks should be where they are up there, far to the north. Okay? Here's Kodiak Island. And the other idea is that, well, this is the triple junction. It's the Kula-Farallon North America triple junction. And, well, it stayed in the same place and all the rocks have moved. Okay?
Yep.
So which is...
Well, I suppose you got some PMAG that says the rocks are moving.
Yeah, so there was actually an older study, but they looked at something called the ghost rocks, which are Paleocene volcanics and interbedded sediments on sort of the south west end of Kodiak Island. Here's where we collected some samples. Okay, here's what some of these look like. So really awesome pillows.
Yeah.
Our awesome field vehicle. And the fun part is that we've got these really cool sedimentary rocks and these really awesome volcanic rocks. And so the sedimentary rocks give us our paleohorizontal. The volcanic rocks give us our really excellent paleomagnetic directions. So we sample all of those. These are these crazy vector diagrams. So you can think of each dot as like an hour of somebody's life in the lab. But what we're looking at is these vectors. We want straight line vectors. So like for this one, we would do a principal component analysis and get our magnetic vector. If you're familiar with these things, you'll see that these are pointing upwards. So they're reverse polarity. Anyway, well-defined magnetic results. So here's how the tilt test works, okay? So on the left, we have something called geographic coordinates. Each of the little dots is an average result of, 5 to 10 samples from a specific site, a specific location. So there are lots of dots on that stereo plot. So in geographic coordinates, those mean directions for each site are as they are with the rocks tilted.
Yeah.
And then what we do is we just have our computer say, let's untilt it by 10%, recalculate everything, untilt it some more, recalculate, untilt, recalculate, untilt, right?
Yes.
Okay. So this stereo plot shows what they look like when the layers are back to horizontal. By inspection, you can see a couple things. One, there's a better clustering. Two, the normal and reverse, so the downward and the upward directions, they cluster together. They're kind of antipodal. And then this plot here, this is just a way of expressing how well clustered they are. So the peak in clusteredness at a confidence interval occurs between that range of confidence, and we just use the 100%. And so here's our passing the paleomagnetic tilt test result. Here's our inclination. So the average inclination of all of those things together, 58 degrees. Okay, so what does that say for our hypothesis? So there we go. So we put North America back for the Eocene, and there we are. So the ghost rocks were far to the south. And this makes sense if we look at offshore plate models that have accounted for the moving hotspots. So this is a figure from the Dubrovine and Tardino 2008 paper. So they accounted for the motion of the hotspots. Okay. this is the plot of their triple junction. So the Farallon Kula triple junction at different ages. And they didn't put the arm here, but I went ahead and did that. So this orange box is where the Paleomag would put the ghost rocks at 60 MA, 58 or whatever. Okay. And so that's where the Kula Farallon North America triple junction was at that time. So that's pretty good. We have volcanic rocks that are not subject to inclination error. We have sediments that give us paleohorizontal. We have good age control. We know where North America was, and so that's a pretty good picture.
And back to the hit and run paper, not all of your sites have all those ingredients present.
That's right.
And so but the Tatlow you've mentioned before, Mount Tatlow has pretty much what you just described as far as the raw ingredients are concerned?
Yeah, exactly. So if you want to go back to the slides.
Good, yeah.
So this is something that I'm sure Jane and Randy will talk about, but these are some summary pictures from Randy's 2006 summary of all of the existing Mount Tatlow stuff, plus some new things that they studied as well. Okay. So all together from 1995 to 2003 to this 2006 compilation, they looked at 8 separate locations, a total of 80 separate sites, 800 plus samples, a positive fold test. So that's on the right. So this is that clustering, right? So the clustering occurs right here. So while the rocks were horizontal, they were magnetized. There's something called a conglomerate test. So if you find clasts of the same rock as clasts in a conglomerate, and they're random, that means that those clasts have preserved their direction through formation, erosion, and deposition into the conglomerate.
Oh, wow.
And these conglomerates, some of them I believe are intraformational conglomerates, so they're part of the whole package. So that gives you a very tight age control. And then they're contact tests, like if you have a younger volcanic rock, like a dike or something, has it reset your older volcanics next to it or not? How does that work? So they have all the tests. They sampled a lot of volcanic rocks. They sampled a lot of the sedimentary rocks. The volcanic rocks and the sedimentary rocks all have basically the same direction. So the question of inclination error dealt with.
Right.
So, this is it. This is all we would actually need. We don't need any other studies because this is so good.
Well, I think we have, 10 minutes left with you before your meeting. And I do want to involve the viewers a little bit, but I think maybe 5 minutes, maybe more. We'll see how much you're into it. Do you want to pull back and talk about social science here a little bit? Like that study right there, for instance. I mean, from your world, what more do you want? You've got all this paleohorizontal, you've got 800 samples, whatever you said, multiple workers working on the same thing. So what have your experiences been at conferences or individually? Are people across the board carefully reading these papers, do you think, or not?
I think it's a mixed bag. And so I think in general, I think I'll say a couple of things. So one, and I mentioned this, I think on Saturday, this is a technique where geology can be a very visual field, right? We want to look at cross sections. We're told to go look at those rocks. We look at them with in a thin section with a microscope. But what we're measuring with the paleomagnetic results, they're not anything we can actually see. So all of these little mineral grains are, probably 100 nanometers in volume, in length.
Right.
They're pretty small things. we're just getting some numbers and we're calculating another number, and we're saying, here you go, here's where this was. And so sometimes that's, I don't know if I understand that or if I want to believe that. It shouldn't be a question of belief, however.
Right.
I do find it kind of ironic that we'll reconstruct the continent using the same method, but we don't want to reconstruct the terrains using the same method.
Yes.
That part doesn't make sense. Yeah. I'm showing one of Brian Mahoney's papers figures because I do want to point out one thing.
Good.
That's kind of a symptom of this. And so if you look at this figure right here, right? So, I've heard Brian give this talk. It's a very entertaining talk. And he kind of starts off with something like this. So we have this reconstruction where there's Baja BC far to the south. Well, that all sounds good. But that's the age of the reconstruction that Brian has published. There's no data that supports that at all. All of the older Baja BC data, they're older. They're 90 MA, right?
Yeah.
If you want to look at a 70 MA reconstruction, use 70 MA data. So
where's his number coming from? Oh, are we going to Churn Creek? I mean,
well, what the number comes from, probably, if I recognize the figure, the number comes from there was a really early paper. Peter Ward was the first author, looking at a limited number of samples from the Nanaimo group, and they came up with a very shallow inclination. They didn't do any attempt to correct for inclination error. But the figure that is used in that reconstruction, I think, is from that older paper. There's been some other results from Ken Kodama and his students looking at using the alignment of the magnetic minerals to correct for and evaluate inclination error. There are other ways to look at the distribution of directions. And so in this paper, we use the ones where the inclination error is corrected for. So this reconstruction right here, all of this is the Nanaimo group where the inclination is corrected. There's also 2 fossil results. So leaf fossils in a 2006 compilation, and also looking at some types of bivalve fossils that place a constraint. So these are these kind of more red ones. That's where the Nanaimo group probably was, according to these data. This is also the reconstruction where North America is a little bit farther to the south. So if you use only North America data to reconstruct the continent, it places North America a bit farther to the south, which can make better sense with some of the provenance models or whatever you want to look at. So, yeah.
Well, this is excellent. We've only got 5 minutes left. I think I'm just going to continue chatting about this social stuff, if you don't mind, unless you just want to change the subject. But the few conversations I had with Merle, the frustration was palpable. I mean, he was a colorful guy, as you know, and had a turn of phrase and all that. But without knowing him, I could feel the frustration. Have you felt that same level of frustration, or have you had a variety of projects where you're not kind of putting all your eggs in one basket?
Well, I mean, I think my, you could be frustrated. I think my take on it is one of disappointment. I think by this time we should know better. So, I'm happy to look at weaknesses in any of these models. Yeah. And that was one of the things we tried to do as we were compiling these results. If we can disprove this idea, that would be pretty fun. But so far it's stood repeated tests. So it's time to consider, as we advocate in this paper, let's consider the geology through this lens. And, it might sound arrogant. Well, our number says this, so everything else is wrong.
Right.
We're not trying to do that, but let's use, if you want to find paleolatitude, you have paleomagnetism, you have fossils. That's it.
And I mean, this 50-year-old data is holding up. I mean, just to bring it back to Merle one more time, like you've done all these methods we're talking about today, revisiting, sampling out, not grouping a bunch of rocks together, and you're still finding the agreement with that original work.
Yeah.
I mean, I just find that fascinating that, I mean, how many other branches of geology do you have that where you just keep coming back to that original message? Crazy to me.
Yeah. Well, and look, I'll also be honest. We don't have it all figured out. This Carmax group right here, I've circled it. That's a problem. That has a pretty large displacement for a young age. Lots of volcanics, lots of sites. So it is one of the things that is difficult to work with the collisional Baja BC model. So we think it might be some sort of tectonic wedging. I've got a cartoon for that.
Good.
There. So this is
yeah.
So I mean, this is a figure from Merle, or not, sorry, Paul Umhofer. Again,
Yes.
He made a reconstruction for a younger age using older data. So sometimes it's a little problematic. But what we're going to propose is that the intermontane is like a escape block. So my horrible drawing right there. But figuring out a viable solution for the Carmax volcanics is kind of an unanswered aspect of this whole model. So it would be really good to figure that out.
Well, looking ahead to the next couple of episodes, I know we're going to be talking about the Carmax a fair amount, and Churn Creek and Mount Tatlow. And so this is, you've set the table nicely for us here. And yeah, I mean, it's never appropriate to just stand and say we've got it all figured out, case closed, whatever. We know the history of science doesn't say that, but just continuing to ignore all this work is fascinating to me. And possibly this series is helping just a little bit.
Yeah.
Looks like you had, I mean, we can sit down on your budget meeting. I just saw your little notification. Maybe should we have 1,000 people sitting in and listening on? Okay, I guess not.
Yeah, you want to go to the high level budget, trying to figure out an equitable budget model for the whole university. Isn't that that's for 2 hours now? So,
oh God,
I'll have to say this is a much better kind of online meeting than going to a 2-hour budget meeting.
Wow.
But that's my future.
And that's your immediate future, but I mean, you've been the department chair at Western Washington University in the geology department for more than a decade, right? And you're continuing with that as well?
I'm in my last term, but yes, I've got 3 more years.
Wow.
Yeah. Then I'm hoping off with good or bad behavior. I don't know what you want to call it.
Well, I know you got to go, but I hope there's more from you with this work. You're such a resource, and I don't know if you have immediate plans or not, but okay, last question, and then you got to go. So did Basil have this plan in place to write this paper, and then he approached you and said, I need a bunch of updated paleomag from you, or vice versa, or how did your collaboration come about?
We've been talking on and off about this paper probably for 10 years.
Okay.
So, and so Basil was finishing up, or had just finished at Minnesota when I arrived there as a postdoc. I think I sat in on Julie Maxon's PhD presentation right when I first got there in 1997, 5.
Okay, yeah.
No, 4. Sorry.
We're going backwards.
Okay. 1994 is when I started there. Yeah. So this has been percolating for a while, and so I think though that it's aged and thoughts have hopefully matured. And so I think
Yeah.
the time is right. My next thing, I have to get this, the Kodiak stuff written up. So
Yeah, please do. Please do.
yeah.
Well, I've thoroughly enjoyed the paper. I know that our viewers have as well. And thank you again for double duty here with us. I really enjoyed it, Bernie. So thank you so much.
Thanks. And glad to do it. So,
okay, great.
see you.
Well, enjoy your meeting. We'll see you
Oh,
later. Bye-bye. That was Dr. Bernie Housen, Western Washington University, Geology Department. He's been there 25 years. And as you just heard, has been taking on administrative duties as well as continuing the paleomagnetic research. And up until these last two shows, I really haven't chatted much with Bernie at all. And I really enjoyed it. And I hope that you did too. It's heavy going. We knew that. And I'm not going to stop right now. I think I'm going to go to the laptop. I think I'm going to go back to the chalkboard. And my tentative plan is to, for the rest of this show, I guess, share where I am with some of these concepts. And it's going to be embarrassing. But my gut feeling is you're with me, and maybe less clear than than my brain. And I think that's okay. I'm talking to myself basically, but I think I'm talking to you too. You know, when we started this series, we just wanted to learn some new things. And it feels to me like the paleomag, you can't really understand it until you get pretty deep. And so we've got two more shows. Jane Wynn on Saturday and Randy Enkin next Wednesday. And I think there'll be more paleomag after that with other people who are using the paleomag and maybe have some direct observations. But if you're losing it here and like, I don't think I'm continuing, this is just going to get harder and harder. I think we're in as deep into the weeds as I plan to go. I think we needed to get into this depth, if nothing else, just to look around and going, okay, wow, this is not easy. Maybe that's all that was. But for me personally, and that's all I can do, for me personally, I have to listen a few more times. I have to read that passage a few more times. I have to go back to Bernie's very clear-cut section of the Hit and Run paper, read it again. And of course, I have to watch the replay of this and listen to those words one more time, maybe twice, and then go to the paper one more time. I'm hoping that's your process. So I'm not just killing time for the next 20 minutes. I want to do some things. And I think the other thing, if Randy Enkin is still watching, and possibly Jane Wynn, our next two paleomag guests are in here. I saw Randy at the beginning. I think I want to do some stuff with you, and we'll just continue to ask our questions for the next two guests. That's kind of weird, isn't it? Instead of live Q&A with the guest in the flesh, I think Jane and Randy might be interested in the common things that you and I want to learn more about as we go to a few of those sites that were discussed. Okay, so in no particular order, am I 5x5, by the way? I'm feeling too confident about that. Can I just pause? It's the top of the hour. I got 20 minutes left. I want to make sure I'm 5x5. Delay in the comments. Jane's here, and somebody said, and Randy's there too. Wonderful. Thank you. Okay. Well, this will be fun. We haven't done this before. We're basically asking questions of our guests for the next two shows. They're in the live chat. I don't think you guys feel obligated to answer people's questions now, but we're kind of workshopping for the next two shows, I guess. Here's more of my questions before we started talking to Bernie, just kind of clearinghouse now. So these are my questions I had from the Hit and Run paper. Bernie, you're saying North America is at a high latitude and not changing its latitude until about 85 million years ago, and then it's drifting southwest? And I think he made that mistake and then kind of corrected himself. Bernie has Churn Creek twice. I don't know, did that make sense? Did this pole position thing make sense? Do we need to do more of that? That was I was rushed, but that was my attempt to do that. Chalk everywhere. Yeah. So I'm just trying to follow in these shows, I'm trying to follow things that just organically pop to the surface. Churn Creek has come up 4 or 5 times in the alphabet so far. I've never even heard of Churn Creek. I'm not even still exactly sure where it is. Southern BC, I guess. But there's some Churn Creek Paleomag in Bernie's paper CH from the insular block. There's also, I don't think I made the mistake. There's also Churn Creek CC from the intermontane. Remember, I asked Basil, is Churn Creek proposed to be the boundary between both of these? Is it straddling both? Basil says, I don't think so. Others, I guess, do. More questions that I had. So again, just thinking out loud here. I was going to say, Bernie, the plutons, are we really moving these plutons? I'm trying to anticipate why, or kind of think about why field geologists continue to resist accepting this paleomag data. I think some field geologists I've talked to say, are we really going to take a pluton where we're really not sure where paleohorizontal is anyway, and you're going to move it more than 2,000 kilometers north, and you're not going to jostle it? Like, are you truly going to take Mount Stuart batholith and have it be, I got an idea. Oh, God. I'm stepping on my expensive chalk. I'm going to have to vacuum after this. Are we taking the Mount Stuart batholith and holding it like a little baby and placing that Mount Stuart baby into this bassinet? Is that a word? Stroller? And are we really taking that pluton and having it move from south of the border up here to central Washington and not having it, that little baby is not going to be jostled at all? I mean, it's 93 million years old, and as you move it, you're not tipping it, it's not waking up and moving, rolling over. It does seem like that's difficult to accept. And yet, where we didn't quite get with Bernie, and we might get with Jane and or Randy, to have all these paleomag results not be in a tight cluster, number one, but then to explain all those paleomag results locally as being, well, it was remagnetized, well, it was tilted, well, it was tipped, well, it was rolled over, well, it was, you're not getting the best results, and to kind of explain away each of those stories and realize that collectively they're all showing that displaced or discordant story in that time window in the insular block. So the collective signature, that's what I was trying to do with that map of North America. The collective signature is tough to explain. And I need to find a better way to express what I'm trying to say right now. You did notice, didn't you, that there was a paleomagnetic flat line in the Cretaceous? Apparently it's called the Cretaceous still stand. The Cretaceous still stand. I'd never heard of it until I read Bernie's paper. Unwieldy poster, huge poster, geologic timescale. Back in the Precambrian and Paleozoic, we don't know anything about the paleomagnetic signatures of the planet because we don't have any ocean rocks from that time. If I fold that over, now I zoom in for you, if possible, with the camera on the Mesozoic. This is the Cretaceous still stand. Why do we have 10, 20, 30 million years without a magnetic reversal? Why do all the rocks of the world, apparently, why do all rocks of the world at 100 million years and stretching from 120 whatever to 85, that's the Cretaceous still stand. Why? And didn't Bernie say earlier in his episode, his appearance today, people still don't know exactly where North America was during some of the Jurassic? I wonder why that is. I've never heard that before. I know this is all over the place. Screw my question. Let me go to the laptop. Screensaver. First time going to the laptop today, very late. NickZentner.com, secure if you must know. Baja. Sluggish. One paper waiting for you, and it's a paper that you've already seen twice in two different shows. I just thought I'd put it on the top yet again. And some of the papers that Bernie was showing us today, here's our pole positions. I don't know if you caught it, but these are the Cretaceous pole positions for Cratonic North America. And if we average those guys together, that's this dot. Then we take those rocks from Cratonic Montana, plot those, which means that North America is a little bit further south. I think I got that now. But look at that. We didn't land with Bernie, but I'm landing now. Here are our paleomagnetic pole positions, or our ancient magnetic north poles for the Mount Stewart batholith, Churn Creek, Nanaimo, Blue Mountains, Ochoco Basin, Carmax, Spence's Bridge. I mean, I'm starting to even remember the names of these things without looking at them. They come up so often. That well-behaved, that expected pole position, that reference pole is suddenly not what it should be. And that's because we're looking at rocks from the wild, wild west. By the way, I really am feeling like experimenting here today. I'm just curious what this looks like on your end. What happens if I do this? I'm on the internet. Here are the two interviews with Merle Beck. If you haven't taken the time to watch them, I encourage you to. This is the one I did with Merle in the summer of 2020. And thankfully, I figured out how to get over to visit Merle in his retirement home last summer. I think you will enjoy those. And his commentary uses phrases that help with our message today. And I mentioned this in the last episode, but I just want to do it here. This is the first of the PBS episodes that we made.
Where they are.
And I know you can't hear this.
Generally from the south to the north, and then they were.
This is a 5-minute clip that I think you would enjoy if you haven't seen it before.
Mount Stewart was part of an exotic terrain that attached itself from here.
Driving up to Bellingham,
to visit Merle and analyzing that rock.
Walking with Merle in the halls of Western Washington University. Bernie was there.
Pretty early. I'm not a founding father of paleomagnetism, but I'm Mount Stewart. A little more than half a dozen places.
All right. Just curious if that video comes through. Let me finish a couple of random thoughts, and then I'm going to look at your questions if you haven't already said them. I'm going to ask again to be able to read things that you want to learn about. So Cratonic North America, those are the expected paleomagnetic pole positions, and then things go apeshit when we start looking at these exotic terrains. Sorry, Patrick. Good. I'm probably going to regret this, but this is the last email that I got from Merle on Christmas Eve. And to me, it's perfect. If you've ever visited with Merle, this sounds exactly like him. So he was bedridden in his recovery bed, watching these episodes. He saw the Brian Mahoney, Paul Link show, and he wrote this. I do remember scraps of what I was thinking while attempting to assimilate Mahoney's ideas as they tortured my bed sores. Probably the most reprehensible was that I owed Brian an apology for having originated a concept so unorthodox that he felt compelled to squander a disproportionate amount of life's creative juices refuting it. After all, arguing the negative rarely is much fun. What a character. Snarky right to the end. Merle Beck on the left, Bernie Housen on the right, almost 10 years ago. Here are the intermontane paleomagnetic results, insular paleomagnetic results, the old paleolatitudes that Bernie has been able to place, very similar to what previous workers had been doing. Another similar plot. Much more for me to learn from these plots, by the way, but at least I have the general idea. And this is maybe, this is maybe the money shot here, where we have ages of magnetization. We have displacement in kilometers. So how much are you swimming the whale north? And down here at the bottom, the Churn Creek from the insular, Mount Stuart Batholith from the insular, Mount Tatlow from the insular, they win the prize for largest amount of translation. Now, I got to tell you right up front, our next two paleomag specialists who are in the chat with us right now, especially Randy, has a different point of view. He's a paleomag expert, but in some cases, he doesn't see these wild numbers, these large northward movement numbers. So is it possible to be a paleomag person and be less than a 7 on the scale of 1 to 10? I think it is. And we're going to visit with Randy a week from today. Also from the new paper, this episode is called Hit and Run Paleomagnetism, right? So here is the summary of the paleomag data after Bernie doing his reworking from the intermontane. Again, here's our Spence's Bridge, Carmax, Blue Mountain, Ochoco Basin. That's Churn Creek, and this is Carmax. Here are the documented translation amounts. You can read it as well as I. I think these are easy to comprehend. I think. Age of magnetization. This is Mount Tatlow, Churn Creek, Mount Stuart Batholith. I'm just picking a few we've talked about. The Methow rocks in northern Washington. The Nanaimo, including some, I don't understand, I forget what these are about. Okay, so it's all there for you. I'll say it again. Merle, I think, was most proud of this paper. 1976, this is the one where everything hit the fan, in Merle's words. Discordant, now that we know that that's unexpected paleomagnetic pole positions as evidence of regional shear. We'll get into it in the next couple shows. Couple final thoughts, and then I'm going to go to you. I'm going to look at the live question and answer, but I don't know how many answers I'm going to have. Probably not many. We are going to have an episode in early February looking at this Gold Beach terrain, and that was definitely a highlight from the Basel show. There's a story here, apparently. Still confused about the Klamath, but I'm at least interested. Here's from the new paper, but I've done it again. I've color-coded it even more. Here's the present-day latitudes, the 60-degree north, the 50-degree north, the 40-degree north, by color. Here's today's 49th parallel, U.S., Canada. Here's U.S., Canada. During the hit phase, the border is up to almost 60 degrees north, but during the run phase, North America is heading south. This thing's down to 50 and heading eventually to 49 degrees north. I'm going to continue to think about that. I've brought it up in 2 different episodes. This is what today's Klamath look like in this color scheme, which I don't think I understand. Oh. And here's the Klamaths during the hit and during the run. So until 85 million years ago, the Klamath exotic terrains are in northwest Nevada, according to Basil's reconstruction. I guess this is the rest of the intermontane here. I'm just fascinated by looking at the relationship of these at different snapshots in time. So the Klamaths go from Nevada during the hit to southern central Oregon during the run, and then today they're like moved down to the northwest California, southwest Oregon scene. It might be a dead end, but I'm wondering if we can learn a lot more about the Klamaths, especially in early February. Oh, we've already made the emphasis that having the insular hit North America is analogous to the Himalayas being formed as India is driving into Asia. But the difference is we're not just colliding, we're also translating to the north. Everyone agrees to a certain amount to the north. Okay, the rest is, I grabbed this from Basil's show. He didn't have this in his show when I was talking to him, and it's not in the paper, but it's kind of a simplified version. Again, just sharing current thoughts I have with you. You might have the same thoughts. This is from Basil, kind of a cartoonish version of those maps we were just looking at, and remembering that the jagged western margin of the Precambrian Old North America, Laurentia, is significant in Basil's mind because I didn't have it till yesterday. When you dock intermontane, according to Basil, that's the hit. I don't really know when intermontane is coming in. I don't think it's coming in 100 like insular is, but whatever. The thing that's interesting to me in Basil's hit and run model is that we send intermontane north, but there's a piece of intermontane that was left behind. And that's today's Blue Mountains. I didn't have that. And I think quickly he said there's another piece of it down here in northwestern Nevada, like a piece of Quinellia, didn't he say? So I've known about the intermontane for sure in all of its glory up in BC, but to have it like not continuous through here, but to have these broken pieces and got crumbs that are caught in these armpits, I find that interesting. And then also from the Basil show, I'm just kind of half reviewing in my mind the last 3 shows. Basil said there's 2 places where the old North America is sticking out. Northern Idaho and California, Southern California. So if we're sending intermontane north, we're going to break off a piece and get it caught in this armpit. That's what I was just talking about, the Blue Mountains. But I think for the first time, I'm starting to see at least the most basic understanding of the Allocetos, which may or may not be correlative with the intermontane history. I don't know. But I think we're also sticking the Allocetos in here. Are we really saying the intermontane was down here? Now I'm back to thinking, I'm remembering Mahoney ringing in my ears right now. Insular and intermontane have to be joined. They have to come south and then go back north. Okay. So this is a different kind of weeds. Where's my mouse at? All right. You still with us? I don't know. Maybe just this process of me thinking out loud spurs some questions, not only for you, but gives our future guests a chance to see where we might be headed, just based on where the host's head is at the moment. Let me just quickly, before we quit, look at some uppercase questions. Let me just read them out loud. And if nothing else, just kind of warehouse some of these questions. And if you've already done it and want to retype it or copy and paste, that'd be delightful. If someone could make a detailed computer animated video, that would be so cool. There is one that we will share on the Karin Sigelak show. Maybe that will be the featured part of the Karin Sigelak show. But of course, that's one model that's different than the hit and run. I think, Peter, you may be wondering, can't we see an animation of the hit and run? I agree. Maybe that would be not easy to do those animations, though. Ian from Australia, is it right to say that it's a two-way street then, tectonically? Well, that's going to keep coming up. Some geologists, possibly even Randy Inkin, want intermontane and insular joined and have them go south and then back north. If that's the two-way street you're talking about, Ian, then it depends on who you talk to. Jim, is the blocker the Archean of the Wyoming province? Seems far east for this story, but you may be on something there. Honey Greg says, where it juts out, sliced off the Blue Mountains. Yeah, that's the concept I have as well. I'm down to live against my will. Speaking of Will Bradley, how does the triple junction geometry play into the location of the Baja BC terrains? Yeah, I was surprised Bernie wanted to talk about, once he got started on that Kodiak stuff, I didn't have the heart to jump in and go, okay, well, actually, we do know about that. That we were talking about that migrating triple junction up in Pacific Northwest up to Alaska last winter with the crazy Eocene. I was surprised he went that young, but I think he was showing the power of Paleomag, confirming a particular model and ruling out another, or favoring one model and discrediting another model. And so, do we really have a migrating triple junction with the Baja BC story? Maybe we should talk to somebody about that in February. John Nash asks, am I all in on moving hotspot plumes? Well, as I spontaneously shared with our guest today, John, I've heard over the years that hotspots are not stationary. This is from somebody who knows Paleomag better than almost anybody. And didn't he say hotspots move at the rates that plates move? So I guess I need to acknowledge it, but I don't know how to incorporate it in my teaching. The Yellowstone hotspot's going to come up in a couple of weeks with the Carmax. So am I all in? I don't know, because I don't understand the significance of a moving hotspot, I guess. Chris, don't the paleo positions of North America just add to Baja BC being a reasonable theory? Don't the paleo positions of North America? That's what I was kind of trying to do, Chris. I'm still not there, but I'm seeing that those paleo poles are so bizarre in the exotic terrain scene versus Cratonic North America, that if you look at the movement of these terrains with respect to Cratonic or stable North America, then that's an underlying major anchor for these discussions. So yes, I see it the same way that you do, I think, still without getting all the details. Jim, what establishes the location of Baja? I'm not sure what you mean there. I'll just let that one stay. Let me just read a few more questions without trying to answer. Jennifer, is any part of the insular terrain visible around Orofino, Idaho, or has it all been covered by CRBs? I'm just going to read questions now. Winston, explain how Nanaimo goes north and then south, sinks 3,000 feet, and then head north. Winston, I think you're low on the 1 to 10 scale based on the tenor of your question. Thank you for the question. I think I just want to read questions here. Robert wonders if Merle's map was using the new data. I don't know. Have we seen one of Merle's maps? By the way, I'm curious right now. Let me go down to live. Has anybody taken the time to look at those top 10 Merle papers? I mean, you can lie right now, just to make me feel good. But one of the many objectives of this alphabet series that we're doing right now is just to share Merle's work. Just the satisfaction of people taking the time to read some of his papers. And I see some yeses there, so that makes me feel good. If nothing else, just to honor this guy by opening some of those papers and looking at them. And keep in mind, those are 10 of, I don't know how many total, 50, 60 papers that the guy wrote while doing this heavy teaching. And his writing style, just like his speaking style, is very unique. So if nothing else, it's just a pleasant writing style, I think. And I thought maybe we would go deeply into each of Merle's papers at one point, but I've decided to go this route instead. I'm going to wrap it up here pretty soon. This is a weird way to spend a half an hour with you here, but you knew this was going to be an odd show as far as the format is concerned, based on our guest needing to go. I'm going to scroll back and look for more questions. Brent, is any north or southward movement along the Wasatch Front in Utah? I think that's too young, Brent, for our discussion here. W. Mann says, Sigloch has a paper saying the Yellowstone hotspot is deep and arises from Baja location. I'm unaware of that. Kirk, do the paleomag positions of magnetic poles confirm with the Milankovitch research? There's a chance I'm wrong, but I think a common thing happening is that we're trying to take discussions from very different time frames and plug them in. I've made that comment over the years with these different series. If we're doing a show on the Ice Age and then somebody's talking about something that happened in the Cretaceous, it's a common mistake because there's all these geologic stories that are kind of interesting and you're just wanting to like stitch them all together. But if we have lots of time between one story and another story, then oftentimes it's not helpful and inappropriate to mix the two stories together if they're separated by tens of millions of years, oftentimes. Try not to discredit your question. 3 more. Did Yellowstone blowtorch cut the plates offshore? Wasn't Mount Stewart part of a bigger body, aka the whale? Where are you today, 1 to 10? I've moved from an 8 to a 5.5. Okay, Richard. When was the last time South Magnetic Pole was in the Arctic? Yeah. Okay, I'm going to wrap it up by saying this. I don't really know how to say it, but I think I want to say something along these lines. My teaching style, whether it's Geology 101 or Geology 351, or giving a public lecture to a group of folks from town or here, it's different levels of geology. I mean, this is pretty hardcore geology here we're doing, but I'm telling stories. And I'm packaging things together to tell a story. And I think that that works for many different kinds of audiences, often at the same time. But it's probably obvious to most of you that I have to pick and choose what parts of geology I want to put into my story so that the story makes some sense. And by the end of the session, there's a nice, pleasing feeling. Like, I was listening, I spent time with that person, they told this story that had a beginning, a middle, and an end, and it all fit nicely together, and I can just click off, or I can leave the auditorium feeling like I learned something, and that it's like a jigsaw puzzle, it all fits together, and we're done. Take a picture, and we're done. I think topics like paleomagnetism I maybe just haven't met the right person, but it seems like it's very difficult to honor the depth of the knowledge and also have it be part of a story that feels good at the end. Now, even just saying that out loud maybe makes me feel like I'm not presenting it properly. But out of all the branches of geology that rely heavily on physics and chemistry, it always feels like you're just a water skipper. You know, I'm talking about myself. I'm just kind of up here on the surface, like trying to tell some stories, like I was doing quickly at the beginning. You know, we can finish with that. I mean, like I think this is real. There might even be a teaching choice or two here that does kind of work. But you know that if we get into each of these statements to a certain level, those nice feelings go away. And maybe that's what these two shows with Bernie are doing for us. We're helping us see why there's been this disconnect. As Bernie said, it's all invisible. Paleomagnetism is data and concepts that we can't see. And as soon as we're talking about stuff that we can't see, there's data there, there's careful work there, but boy, can you get there easily and embrace it easily with tactile reactions? I'm talking only to myself probably right now. But that's the challenge of trying to find ways to continue to learn Paleomag with these experts and finding a way that is going to feel satisfying at the end. Maybe that's impossible. All right. A toast to you. Here's to you for joining us with this hard subject matter, and you made it till the end. Thank you. Here's to your health. I'm not sure what the weather's like in your area, but there's been extreme weather of all different forms, shapes, and sizes lately, it seems. I hope that you're doing okay and that your health is as good as can be expected. Here's to the health of your family and friends, everyone in your community. Here's to Bernie Housen for spending 2 shows worth of concepts and details with us. Thank you, Bernie Housen. Here's to Dr. Merle Beck, longtime Western Washington geology professor who passed away a week ago exactly. Here's to you, Merle. I've been emailing a little bit with both Jane and Randy. Jane coming in the next show, which is Saturday morning at 9 a.m. Pacific, and Randy a week from today at 2 p.m. Pacific. And I have a decent idea of the papers that I need to read. I'm going to work from scratch with Jane Wynn's work and Randy Enkin's work. I've just barely gotten started. So I've got a lot of reading to do between now and then. But I'm particularly excited about those 2 shows because I've heard of their names for so many years now. And I'll get a chance to meet them for the very first time tomorrow morning as we test the audio-visual, and then when we all get to meet them this coming Saturday and the following Wednesday. I know that we're going to Mount Tatlow study. I know that we're going to the Carmacks. I think we're going to Churn Creek and probably other places as well. And so our journey continues, dear friends. Thank you. I love you. And goodbye from Ellensburg, Washington, USA. Enjoy the rest of your day, and I'll see you Saturday morning. Goodbye.